Today we are going to discuss about BioPython. Now, the name suggests that the Python and this programming language is utilized to solve the biological problems. Okay, and it is mostly related to bioinformatics, and it is a free project. Okay, free project means some developers have already developed some codes in Python which are exclusively for biological data analysis purpose. Okay, and this BioPython is a package of useful modules to develop the bioinformatics application. Now we have seen that what are different modules, right? Say for example, we have used import math or import ray. The last class we have discussed about the regular expression. So there are certain codes which are written in Python and they are grouped into a module. Okay. If we are trying to utilize that module, we first need to import that module, and then we can use several methods associated with that module to write different codes. Okay. Now here BioPython is a large package. That means a number of modules are included in this package. Okay. So we will see how we can use this kind of package and associated modules. Now, BioPython started as an idea in 1999. Okay, and it was an initiative by Jeff Chang and Andrew Dalke. Then the project began to take code form in the month of February 2000. So you can get an idea. It is not very old package, only 2000, and now it is 2021, so 20 years almost. And in 2000 only, the first release of BioPython was made. But at that time, this BioPython was in very nascent stage with small number of codes. Now, uh, it is a huge collection. Many scientists are, many developers are regularly updating these packages or the modules or the codes available with this BioPython. Okay, so if you go to this site biopython.org, you will see that number of links are available. So how to download the BioPython, how to start with writing code using BioPython. Okay, and this cookbook, that is some working examples, and we will follow this tutorial cookbook to apply this BioPython to analyze the biological sequence data. Okay, now you can click on any of these links and you will see that thing about the documentation. So from here, the BioPython tutorial and cookbook, you can download this PDF. It will help you. We will go to follow this cookbook to see how we can apply this thing. Okay. Then there are many documentation available. Now, the first thing, you need to install this BioPython in your computer. So for that, you can go to download page and you will find the BioPython version. So you can use this zip file to download and to know how to install one software in your Windows machine. So that is very easy. Okay, or you can use this pip management tool. So you need to go to the command line to install this BioPython, and there you need to type pip install BioPython. Okay, so the steps are described here, how you can install or uninstall BioPython. If you are using Linux machine, so there is different commands. You can use that too. Okay. Now, these are the dependencies. As it is a huge package, so Python, obviously Python must be installed in your computer 3.6 onwards. Then C compiler, obviously that is there. If Python is installed, it will be there, and the NumPy, that is also required. If it is not there during the installation process, it will automatically get installed. No problem with that. So installation is very easy, only click based installation process. There are a number of old releases. So don't need to go to that part. So better you can use the updated version, this one. Okay. So all these things are freely available. You don't need to pay anything to use this package. Okay. The source code are available, and you can contact uh, to this project by a mailing list also. If you are facing any kind of problem, if you are facing any kind of bug, so you can mail them. They will respond. Okay. So there are many platforms available. All right. So this is the basics of BioPython. Now we are going to see uh, some examples of this kind of programming. Okay. Just for a minute. Wait for a minute. Okay. Is this screen visible?
Yes, sir.
All right. So as we know that BioPython is a part of family of Open Bio project, also known as BioStar, for which institutionally it is a member of Open Bioinformatics Foundation, OBF in short. And due to the open nature of the project, tens of people have contributed code from diverse fields within bioinformatics, from information theory to population genetics. And that's why you can get different kinds of help, different kinds of modules within this large package. Okay. So how do you know that you have successfully downloaded and installed your uh, BioPython package in your computer? So for that, you need to type two things, two lines. One is import space bio, B in capital. So import bio, then you print bio dot underscore underscore. So there are two underscore, okay, two underscore, then version underscore underscore bracket close. If you run this, you will see that which version of BioPython is installed. Okay, so in case of mine, that is 1.76. Okay, so that is the first thing. You need to check that whether your machine has the BioPython. Okay, next is we are trying to deal with the sequences. Now, as a biotechnology or bioinformatics student, you know well what is DNA and RNA, how they are represented by the letters. And in programming language, this sequence is represented by a seq class, capital SEQ, seq class. Now, seq class is defined in bio.seq module. Bio.seq module. Now, what is this class? This class concept is coming from the object-oriented programming. Those who have done some other programming languages like Perl or Java or C, not C, Perl or Java, uh, you will find that you can define some class, and within that class you can write some functions, you can write some uh, codes, and you can use that class to build a module, to build some module. Okay, so within this bio.seq module, the seq class you will find if you are trying to know how this hierarchy is formed. So you can go to any object oriented uh, programming site, and then you will know in more depth that how this kind of classes are written. Okay, now we are going to use the power of such kind of uh, modules. So for that, we need to do first, we need to import that module. Okay, so we are going to import seq class. So here SEQ, that is a class. Where it is found, I just mentioned that that is within the bio.seq module. So earlier only we have imported some modules, right? That import ray or import math, that kind of thing. Now, as this seq is a part of this module, so we need to write from bio.seq import seq. Okay, from bio.seq import seq. Now we are defining the sequence as AGCT. You can write anything, you can write anything. So that is a string basically. That might be a protein sequence, that might be a DNA sequence. So just like in our case, how we in earlier case we have seen that how we have defined the string, just like that here we are defining the sequences like this way. So SEQ within bracket, within parenthesis, within quotes, the string, the sequence. Okay, and that we need to store in a variable. Okay, now remember that this seq and this seq are not exactly same. This is in capital letter, and this is the rule. You need to write capital S to mention that this is you are going to use this seq class. Okay, if you by mistake write small s, so then it will not work. Okay, so you need to follow this thing, but you can write the variable name here in the left hand side. That is up to you. Sec1, sec2, you can change this thing. You can change this variable name. There is no problem, but you cannot change the structure of such command line. Okay, so that is the first thing you need to remember. Now you are printing this sec simply. So using this sec class, we are going to print this part of sequence. So if we print, we are going to get this in return. Okay, but if you you can print in Jupyter Notebook using sec also. So if you print only sec, then it is showing that whole thing. Okay. So note that if you in Jupyter Notebook, if you are going to only write sec here, so that will give you the in return capital SEQAGCT. Okay. So you might be confused that you have used that SEQ variable, and if you are printing that variable, so all these things have been printed. Yes, because that is not the output. Many times I have mentioned that. So for that you need to print the sequence. So that's why it is better used to write this print sec. So then you are getting the output only, that is AGCT. Okay. Now um, let us move to the file, that is tutorial file. So far, is there any question how we can run this thing? Any doubt?
স্যার
Yes.
স্যার বায়োপাইথন না থাকলে কি জুপিটারে চলবে না?
No, you need to install BioPython first, so then only you can run these codes.
Oh,
Okay.
okay.
Because this is dependent on this, what I said, this bio. Okay. So you should import this bio package first, so then only it will work. Because everything is dependent on this bio package. You can see that bio.sec.io, bio.sec. Every time you need to write that. Okay, so it should be there. Okay. So is it fair? So this is the BioPython cookbook. This is the latest version, 2021 June. Now, if you browse this book, you will find that lots of stuff has been already given with small examples. Okay, we will try to see the examples from this chapter 3 and chapter 4, and to some extent FASTA file handling. Okay, so this thing we are going to learn from this tutorial one by one. So first we will okay. So this is a chapter 3 sequence object, and we will start from here. Okay, so let's start that. So we are going to write this thing in a file from bio.sec import sec. If I try to run this, it is working. See, no error. So that means I have the bio uh, package and I have successfully import the sec class from that. Okay. Now, in the last example, we have seen that how we can define a sequence. So this is how we have defined one sequence and we have stored that sequence in a new variable. Running that, it is also running, so no problem with that. Now, if we are trying to print the nucleotide and its position, okay, so we have used for loop for that. Suppose in the output we are trying to get that 0G, 1A, 2T, like this. So index number and the nucleotide. So if you can remember, we have done this using a for loop, right? When we have done for loop example, so then we have used that thing. We have done this, and for that we have also used enumerate function. Okay, enumerate function. Now we can explore that for loop and enumerate thing here also. So we can write for index comma letter in enumerate this variable my underscore sec, and what you want to print index and letter. So we are going to print that. This is just a process how we can print these values of index and letter. If we run this, we are getting the same output. Okay, 0G, 1A, 2T. So you go back and you can check that we have already done this thing during the for loop example. But here we are using the sec function, sec class of bio.sec module, and utilizing the power of for loop, we are printing this thing. Okay. Now you can print the length of this sequence also. Exact same sequence, same command, print len mysec. Okay, so very easy. Now if I tell you, okay, so fetch the 0th position element, so what you will do? You can write that what we need to print to get the first or 0th element. Print, what you will print? Anyone? Are you listening? My question is, if you want to print this G, so what you will write? Print, what you will print? No one can answer this.
Sir, sequence 0.
Sequence 0. Which sequence? Which sequence? Are you talking about this sequence? like this, or what? Are you not following, or is there any difficulty? This is a very easy example actually. So if you are thinking that you have done lots of things on Python and this, so why do you need BioPython? Uh, so then probably you are going to make a mistake, because those are very basic things, and actually nowadays you are going to use these BioPython packages because many of the codes are written in utilizing these packages, and if you don't know how to use this thing, so even if you are very good in Python, normal Python, so then also you will be in trouble to solve that problem using BioPython code, right? So for that, uh, my suggestion is better to practice these things. Otherwise, if you are facing any kind of problem, you can discuss with me. Uh, Otherwise, the basic Python is for very basic level actually. And inform your friends also that most of the questions will come from this Python. Okay, because that is the main thing I mentioned in the first class, that BioPython is required to solve the biological problem. Okay, now Python you can apply in different fields, no problem with that. Normal Python code, ordinary Python code. But these are the facts you, the bioscience students, must know. Okay, so that sake will not work, because think logically, you have already used this variable to store the data, so that should be this variable name, and if you use this, you are getting G. If you change this with 1, so you will get the second letter, right? If you use -1, you are getting G, the last. So the Python, ordinary Python syntaxes are also valid here, no problem with that. But you should know how to import that thing, how to use that classes, how to use that object, so that you can utilize the already written code in BioPython package. Okay. Now, suppose you want to count, you want to count how many uh, how many G's are there. So what you will write? MySec dot count G, right? You can check that 2G. Okay. Now suppose you want to identify some motif. in the last class, we have seen that how we can use regex for that. So here you can search for motif also, or any pattern using this small trick, that dot count. Suppose you want to identify that whether GAT is present or not. So if you count GAT in that sequence, and if you are getting any hit, so obviously you can say that yes, GAT is present, isn't it? So count is a very powerful method by which you can identify any substring within a large string. Okay, got it?
Yes, sir.
Okay, okay. Now you can calculate something. Okay, suppose you want to calculate that GC%. So already you have done this. So you can write this one line code. Okay, you can write this one line code to calculate the percentage of GC. So what you are doing, mysec.count G, mysec.count C, add up, and then divide that with the length of mysec and multiply by 100. So you are getting that 60% of GC. If you calculate this GC percentage, you will get 60, isn't it?
Sir, how can we install the BioPython?
So that we have already discussed. You can go to the download page. You need to download that thing, and you need to follow the instructions to install that BioPython. Okay.
Okay, sir.
Okay. So that is one way how you can calculate the GC. Now there is a package known as not package. There is a module which is known as bio.secut. Okay, and which has already one method, that is GC. So we can use that too. So what we need to write? We need to write this from bio.secutil import GC. Obviously, before that, you need to write this also. Okay. You need to write this line, and then you need to import that GC. Then if you write the same thing, mysec equal to sec, and now if you want to use this GC of mysec, so you are getting the same exact result. Okay, so you don't need to write this line also. You need to use only this method, and you can use this method by this way, GC and the variable name where you have stored the data. So it will calculate the thing.
Sir, what is the seek utils here?
So that is the method, that is the associated module. Okay, where this object is found, where this object is written. So that is the seq-utils. Okay, that is the seq-utils method. Okay, so sorry, seq-utils module. So from bio.seq-utils, you need to import this object. Okay, this class. This is the class which is inside this module bio.security, same as this. Okay, so that is a name of the module. So many this line is written under this. So there is a hierarchy, how they have stored the data, how they have stored the different codes, and for using this kind of concept, you need to import first, and then you need to use that thing. If you are not importing, you just try to run this GC method or GC object, calling the variable name, it will not work. Okay, so suppose you forgot this, and we have already run this thing. Stop this kernel. Now see, name GC is not defined. That means you need to import the GC first. Otherwise, you will get some error. Okay. Now it will work. Okay. Now using this splicing option, you can slice the sequence. Sometimes we need to cut a part of the large sequence. Okay. So say for example, we are going to take another sequence. Suppose we are taking this sequence. Okay. Now we want to extract the sequences from 4th position to 12th position. So for that, we can write this, right? And to use this, we need to again write one line, that is this line. So we are importing sec class from bio.sec module. We are defining our sequence line, and then we are trying to fetch the sequence from 4 to 12 position. Okay, so you are getting that sequence GAT GGG. Now we'll find that 0 1 2 3 4 4 GAT GG CC. Okay. To print this, we will get only the sequence part. Okay, this part. Now you can change this position, and you can get that much of sequence. Okay. So you can use the start, stop, and stride also to get a different thing. Like if we write print my sec 0 colon 3. Okay. Now look at the sequence what we are getting. If you are writing this G C T G, now you can look at this, and you can tell me what is going on if you are writing this code. That is the simple slice functions utilizing the colon operator, right? Can anyone tell me? Why is this printing? Can anyone tell me? Okay, so then let me explain that
At a complement base.
complement base. Where is the complement base? Huh? See, by this colon operator, you can use the start, stop, and step. You can mention the start position, the stop position in between these two colon, and then the steps. Now here you have not mentioned any stop position. That means whole the string will be read. Start position from the 0th position, and step size is mentioned as 3. So that's why it is taking Z first. So then it will go for third element from that position. So 0, 1, 2, 3, right? So C has been printed. Then again it will jump from the third one, G, A, T. So T is printed. Like this way, it will print the third element from this sequence. Okay, every third element. And now, using the power of this colon operator, you can reverse the whole sequence in one line. If you write this, the whole sequence will be reversed because you are printing from -1. So that means from this side, right? So you can see that print this and you will get the reverse thing, right? Now in ordinary Python code, if you want to reverse the string, you can use this colon operator, and here also you are using the same thing. Okay, all these examples are from biological point of view, so these are very much interesting to you. I hope that. Okay, now
Sir, can you please explain the last thing? That is the colon -1.
yes, so -1 is what? -1, that means the step size is -1. Okay, so it will start from this position and it will print whole this thing from the back side, and by default it will be reverse. So -1, -1, -2, -3, -4, this will be the step size.
Sir, but here the start codon is not there, right? I mean, 0 is not there.
No, that is the start and stop, but as it is moving from the back side, so it will be counted from here. It will be starting from the, by default it will start from here. Okay, so it will go from the start to end, but by default the step size is -1, and for that you are going to get that thing. This is a trick. This is a one liner. If you now if you are writing this, so what you will get? you are getting the same thing, right? Exactly same sequence, isn't it? Now, if you are changing the step -1, so it is counting from here. It is reversing the whole string. Okay.
Okay, sir.
Sir,
Yes.
sir, please, let's assume that someone forgets this code, this code. Is it possible to get an answer?
I'm not getting you. If you forget,
The code, like this print my sick.
my 6, then
Yeah.
what will happen?
Is he going to get a? Are we going to get answer, or is there any other way that we can get answer? And are we going to memorize all this code?
Okay. So you are saying that if you forget that this line, that is
Yes.
colon -1.
Yes.
Yes, but then you need to write the code in another way so that you can reverse the thing. There is other options also, but it is a trick that how in one line you can do the thing. So you need to memorize this trick. Yes, that is true. You need to memorize this trick. That you need to memorize this trick with logic. That what is the logic behind this construction colon -1. Okay, so that is for reversing any kind of string. Yes, that should be memorized. Otherwise, how will you do? But you need not memorize that 0::3 because these are very obvious that you can pass these numbers. You can pass this start site or stop site or the step size. Okay, that you can pass using this slice operator. So when we have discussed about slice operator, you go back and you can check that we have discussed a lot of examples using this slice operator. Okay, and this is an example of that, how we can utilize that slice operator to reverse a string. Okay. Okay, so we have done many of the things. Now one more simple example. Suppose we want to concatenate two sequences. One is this, another is this. Obviously, for writing any code with sequence, you need to import this line. So now you know what is concatenation, right? Now, if you add these two sequence, it should be concatenated, right? And we will get the output as this. If you print, if you are saving this thing in my pick one and then print my pick one, so you are going to get the concatenated sequences. But think logically, is it right? Is it right? Can anyone tell me whether I am doing the correct thing in biological science? Hmm. There is a mistake. See, we are trying to add protein sequence with DNA sequence, even though those are marked by one letter code only, but then also it is not the correct way. We cannot add the protein sequence with DNA sequence, right? So every time protein sequence must be concatenated with protein sequence and DNA sequence must be concatenated with DNA sequence. So this is not the correct thing. Please remember that thing.
So can I concatenate the protein sequence with its coding sequence? I mean, its mRNA coding.
No, how? That is the amino acid sequences, and you are trying to concatenate with a RNA sequence. Is it possible? Concatenation means what? You are just trying to glue the two sequences. Okay. Now one amino acid sequence and one mRNA sequence. Can you merge these two sequences? That is a wrong concept, right? What will be the use of this kind of code or this kind of string or this kind of sequence? No use, isn't it?
Yes, sir.
Okay. So all right. So next week we will meet again. Today's time is almost over. So you can start writing your code in BioPython if you can download and install your this software or tool into your computer. Okay. So we will discuss again more examples next week. Bye now.